with describing and summarizing data. And as you all know, we have some common ones that we are familiar with. We have the histogram, we have the bar chart, the box plot, and so on and so forth. So for univariate, that means one variable will be starting up with a histogram. And to do that, let us use one of our data sets from our example data set. So we go to File, Example data set, install with STATA, then auto.dta. Then we click Use. Or simply type "Please use auto," the way we used to type it. Please use auto. So once we are done with that, we can quickly look at our data set by pressing the data editor. We'll see the data set. You can see the variables: make, price, MPG, ref78, trunk, weight, length, ton, displacement, foreign. This foreign is categorical. You can see domestic and foreign there. We shall be talking more about that later. So now, the first approach that we use under this histogram is a histogram under continuous variable. Then another thing that I want to say is that most of the graphs that we shall be considering today, we are going to use the menu approach. Why? Because the construction of graphs involves so many options that it might become somehow complicated. But if we pass through the menu approach, we can get the commands out, then send them to our do file for future usage. So I believe that if we pass through the menu approach, it will be easier for us to get the basic understanding. I also want to say that what we are going to talk about here, they are just the basics. So there's still need for us to do some other explorations on our own to get so many other dimensions to the issue of a graph construction. I also remember that in our Google Classroom, under STATA resources, Prof has posted something there. You may wish to check. That's STATA cheat sheet. If you check it, you see that there you see some portions there for graphs. The commands are there for the type of graph that maybe you may likely wish to construct. So that STATA cheat sheet is very, very good. So you may wish to consult that too after the lecture. So for us to go to our histogram now, we go to graphics. From graphics, we click histogram. So this window pops up. Histogram for continuous and categorical variables. So you can see main, if, in, weight, density plots, art plots, y-axis, x-axis, titles, legend, overall, by. Okay, so we are starting with continuous. So it's already highlighted. Let's select our variable. That's MPG. Let's select MPG. So if we select MPG, we leave the under the y-axis. Let's just leave it like that. And then we click submit. So you will see that a graph window has been opened. So you see density, then you see the bars 1, 2, 3, 4, 5, 6, 7, 8. So you will notice that I clicked submit. I didn't click OK. I clicked submit because I want that histogram window to remain open so that modifications that will follow after will be possible without having to go and be opening another one again. So once we click submit, we still retain the window so that we can do our modifications. So now that we have this graph, the first thing that we think we should do, we can reduce the number of bins. If we have so many bins, it means that we are not really summarizing our data enough. If the number of bins is also too small, it means we are over summarizing. So we need to strike a balance between that, between whether you have too many bins or too small bins. So now let's check this. You check that beans box. Check it, and let's say we reduce the number of beans to 3. We reduce the number of beans to 3. I hope you are following me. Then, under y-axis, before we have density, but we are used to frequency. So let us change that density to frequency. If we want to add height labels, we can also click this. We can also check this box, add height labels to bars. Then we click submit. You can see that the bars are reduced to 3. You can also see the height labels.
Excuse me, doctor. Excuse me, doctor.
Hello?
Can you repeat, please? Can you repeat from where you started?
After
highlighting that, after displaying that graph, can you repeat from there?
Okay. The first graph. Are you talking about the first graph or
yes,
this one?
Yes. Immediately after opening up the graph, then you started with that, the bin what? Can you start from there?
Okay, the beans. I said that the beans, that you need to choose the number of beans appropriately. It should not be too much. It should not be too small. If it is too small, you are over summarizing. If it is too much, if it is too much, that means you are under summarizing. So you have to look at the appearance. If maybe you see it's like 6 or it's like 7, you look at the appearance, the impression it gives you before you conclude. But based on the example that we have here, we have decided to reduce the number of beans to 3. So now what we are saying is that we should be clicking submit so that this window here, histogram window, we can retain it for our editing, modifications, whatever modifications. So after that first graph, we decided to check this box, beans here, the first one, we check it, and we change the number of beans to 3. We moved from density to frequency. Then we decided to add height labels. You may not add it, it's not compulsory. We just decided to add height labels to bars. And then we clicked submit. So that's how we arrived at that particular junction. So now that we have gotten that, we can also go to titles here. We can go to titles. We can come under this title here. We can give our graph. We can give it a name. We can call it mileage graph. Then we can go to note and say source. Example data set. And then you may also add subtitle, caption, whatever, but we can now click submit. You can see that we have that title now, mileage graph reflecting, then the source, example data set, also reflecting.
Excuse me, ma'am.
Yes.
Sorry. I didn't know how you got to the title. I didn't know how you get there.
The title, go to titles in that histogram window. You see titles there. Main, if, stroke, in, weight, density plots, add plots, y-axis, x-axis, titles, legend,
Okay.
overall, by. So
Thank
click
you.
titles.
Same.
Under that, okay. So after you have inserted the necessary information, you click submit. So another thing that we can do is to change the look of the graph. We can change the look of the graph, maybe the color, for instance, by still going to that histogram window. Then we go to overall, and then we come to scheme. You can see scheme here. Under scheme, you see default. Go to that drop down button. You can select any one you like, but let's select STATA journal. STATA journal. After that, let's click submit. You can see that the color has changed to the format for STATA journal. So another thing that we can do is to include the legend. Include the legend. So again, we come to that histogram window. We click legend. So under this legend now, you can see legend behavior. Default, show legend, hide legend. So click show legend and then submit again. So you can see the legend frequency. You can see the legend here now. So now, if we want to talk about the line for the normal density plot, we come to density plot here. Density plot. You can see add normal density plot, add kernel density plot. So let's check the box for add normal density plot. So after that, we submit. So you see that the line has been added, and that now enables us to visualize in terms of normal distribution, now whether it's a positively skewed or negatively skewed or some other properties that we may want to talk about under the normal distribution. So I think that's that under continuous variable. Do you have any question on that?
Hello, ma.
Yes.
Hello?
Hello, ma. How do you get to that histogram, please? I'm just joining now. Sorry.
From the histogram window.
Is it from
click density plot? Click density plot. Then
me,
check that box, the first one, add normal density plot.
Hello, ma. Can you hear me?
Then you
okay, is it on that graph?
Yes, yes.
Then histogram.
Yes, of course.
Okay. Thank you.
You're welcome. So we can clear now. And then we still return to our use auto. Okay. After use auto, we go to graphics. From graphics, we go to histogram. So, but we first of all need to check, because what we want to do now is the one for categorical variables. The first one we did talked about continuous variable. So now we need to check and see that everything is in order. Like this, we check this. We come to density plot, we remove it. All those things that we did the other time, let's remove them. Default. Okay. So
Please, ma, can you, ma, please, can you increase the font size
of the results?
Yes.
Okay. It's not big enough like this. Is it better?
Yes, it is better.
Oh, okay.
It's better
So now we So we go to our histogram window. We change the data to discrete. Then MPG still. We still have our frequency. Let's remove this check for add height labels to bars. Then we click submit. You can see now, this is our new graph under that of categorical. We selected discrete. Okay. So the next thing we can do now is to go to by. We go to by. We click draw subgraphs for unique values of variables. Draw subgraphs. What do we want to do? We want to be able to get a clearer picture of what we mean by data are discrete. So we're going to look for a categorical variable like that foreign. That foreign, the other time, I show you that it has been categorized into domestic and foreign. So now we will click that foreign here under variables. We go to foreign. So after that, we click submit. see what we have now. We have domestic, we have foreign. The histogram for domestic, the histogram for foreign. So another thing that we can do to get a better understanding is to rearrange these two histograms. We try to bring the foreign under the domestic so that we can easily see what is actually happening there. So to do that now, we go to
how we got here, please. How did you get subgraph, please, ma?
We from the histogram window go to buy. The last button there, buy. Click buy. From buy, check the box, draw subgraph for unique values of variables. Then under variables, click foreign. So after that, you click submit. So now,
Okay, thank you, ma.
you're welcome. So what I want to do now is to try to rearrange the domestic and the foreign in one column so that we'll be able to have a better view of the information that we might likely get from the graph. So what we do now is we come to subgraph organization. Click subgraph organization. You see when you do that, another window pops up. Subgraph organization window. Under style now, click default. The default for this is a rows for columns. Under rows for columns, you can see default there. Rows stroke column, you see default there. We change it to column. We change that one to column. I hope you are following me. Then we check this box, other groups by column. Please make sure you check that, other groups by column, because the default is row. That's what we first of all obtained. We obtained the one that goes row wise. We want to move column wise now. So we check that box for column. Then after that, we click accept. After clicking accept, then we click submit. You can see now that the domestic is up, the foreign is down, and you can easily see what is happening. By looking at this, you can see. You can easily do the comparison between domestic and foreign. So that's that. If we want to include the totals, you know, we have domestic, we have foreign. If we want to include the totals, we are still under buy. So what we just need to do is to check this box here, add a graph with totals. Add a graph with totals, you check the box, and then you move again to subgroup organization. That window pops up again. Under style, still maintain default. You notice that the rows and columns section, you still have the columns there. Then we still have other groups by column, is still checked. So that means that we can accept. Accept. Then we submit. So you can see now that we have domestic, we have foreign, then we have total. So we can compare, we can make a comparison amongst the three now. So just as I said, there are still so many of these things that can be done. The other thing that I want to talk about is this start graph editor here. Once we click it, the start graph editor here, once we click it, you see that on the right hand side here, you can see object browser, graph, plot region 1, and so on and so forth. So you can actually work with that also to do some modifications. For instance, if I click this place now, you can see that those values there for frequencies, they are actually labeled vertical. I can come now and change it to horizontal. You can see that it has changed to horizontal. We can do so many other things. Just explore and get a feel of how these things work. So if we look at all the things we have been doing, you see that all the commands are already here. So we can send all these commands to our file, and then they'll be useful for us maybe when we have our own project and they want to do something like that. So based on what we have talked about, I think we can safely stop on the histogram. Do you have any question on histogram before we proceed?
Yes, please, I do.
Okay.
I noticed that for the second part, we're mostly working on foreign. How come our syntax is still showing MPG? When
the univariate that we are dealing with is MPG. That is the univariate, the variable That is the variable we are dealing with, MPG. But that MPG now, we now want to see it in greater detail. That is why we are now saying by foreign. That's under categorical now. The first time we started, we didn't say by foreign. We just plotted the something, but because we wanted to see in further details, okay, by foreign that is already categorized into domestic and foreign, what else can we say about that MPG? So in terms of foreign now, we can further talk about MPG. Have I answered your question?
Thank you, Doctor.
Okay, let's move to box plots. You know, box plots generally, you know, the other time we talked about exploring our data sets. So one of the ways by which we can do the exploration is through the use of a box plot. The box plot will allow us to see our data set in a greater detail. We'll be able to see the spread. In fact, those that are far away from others, they are called the outliers. We'll be able to see them. So once we notice that, we can say, okay, there are outliers in this data set. Let us go and check what might have happened, what might have occurred. So whether it's due to error or they are genuine values. So that is the work of a box plot. So to do that, again, let us clear. So we are still using our 6-use auto. So we move to graphics again. From graphics to box plots. You can see another window coming up. That window is graph box. The graph box. The graph box. So you see main, categories, if, in, weight, options, boxes, markers, y-axis, titles, legend, overall, then by. So we also have orientation, just like we had to. If we want it to move vertically or we want it horizontally, so we are still maintaining the vertical. But if we want horizontal, it's also okay. So again, the variable that we are still considering is our MPG. MPG. Click MPG under variables, then submit. You can see the graph now. You notice that the median, this line here is talking about the median. If the data set is actually normally distributed, this line that is the median is actually supposed to be in the middle of this box. But as you can see, it's not in the middle. Another way of getting whether the data is normally distributed is to look at this edge here. You look at the edge, the distance between this edge that have the adjacent values and the box. Then look at the distance between this edge and this place too. If they are equal, then you say, okay, the data set is normally distributed. So, but as you can see now that this line is moving towards this lower edge here. So you cannot really talk about, you'll be talking about positive skewness. It's skewed towards the down values. Okay, so, and you can also see the outlier. This point here is a value that is outside. It's outside everything that we have here. So that means that it's not within the range. So we may want to check what is actually happening. What is wrong that we are having this one outside. But as we said the other time, if we have mileage like this alone, we may not be able to get a better picture. So what we can do is to try and get a better understanding of what is happening to mileage. So we can go to buy in our graph box. If we go to buy, just like we did under histogram, if we go to buy, we click draw subgraphs for unique values of variables. Draw subgraphs for unique values of variables. Which variable are we considering? We are still considering our foreign. We are considering foreign. Then We click submit. So you can see now that instead of having ordinary MPG, we have MPG now under domestic and under foreign. And we have a better understanding. As you can see, there is one outlier displayed here under domestic, another one under foreign. If you look at that of foreign very well, you see that this line, we may need to subject it to further test, of course, of normality, but this line seems to be in the middle, not exactly, but it seems like this one is kind of in the middle, but this one does not seem to, if you look at this distance, this one is longer than this one. So by and large, you see that we're able to get a much more detailed information than if we have remained at our just mileage level. So we can also use categories. If you don't want to use by, you can also use category, but you check, and then you come to categories, and you now say, okay, hello? Hello? Please, I can't hear you. I can't hear you. Can you repeat the question?
Well, please, if you can send your question to the chat box if you're having sound issues. The Oladipo job allowed to be, please, you can ask a question, unmute and ask your question. Okay, Elu Dodu Sunday, please, you can ask your question if you have. Otherwise, Dr. Tekri will go ahead with the class.
Okay, let me continue. So I was saying the other time that if we don't want to use by, we can also use the categories. In fact, in our lecture notes, you see the by, then you see the over, as in for the command. If we use the command, if you use by, you get the by. If you use categories, you see the over. So you can check and try all those commands also. You see that they give the same result. So what we are saying is that if you want to use categories, what you do is just to make sure that you uncheck what you have done here, and then you come to categories here, and then you click. If it's just one category like we did the other time, group one, then grouping variable will now be our foreign here. Since that's the only grouping variable that we add, so we submit. So you see that we have the same result. Okay, so that's the use of by and the category. In the command, you see the by, then you see the over. Okay, so by the time you are trying it from the lecture notes, you see that. So the next thing that we want to talk about is if we feel that we should not display the outliers that have been noticed. If we feel we should not display the outliers, what can we do? So in the course of preparing, I noticed that there are some little modifications in the lower version, between the lower versions and the higher versions of STATA. So if you look at this screen now, you will see that if we move to boxes in the graph box window, if we move to boxes, under global box settings, I have here gap between boxes, outside gap, fill intensity, outline intensity, which I notice is a little bit different. It's a little bit different from what we have in STATA 14. What we have in STATA 14 under global box settings, those of you that are using that, you see that there is a place there. The first one is do not plot outside values. Do not plot outside values. So if you are using that one, do not do STATA 14 and above and some other versions, you see that one, do not plot outside values. You check that box. Once you check that box, you click submit. But in my own case here now, this is a STATA 12 here for this particular presentation. This is STATA 12. So I will have to go via the command to use the no out command. Graph box MPG, that is the first one, graph box MPG. over foreign. Over foreign, then no out. No out means no outliers. You can see that the outliers are gone. So if you are using STATA 14 and others, just check that box. Do not plot outside values. Once you click that one, that box, go and submit. You see that it will remove the outliers, and the command, the codes will also be similar. So that is that. That is that. Please, do you have any questions before I proceed?
Yes, ma, I have a question.
Yes.
Can you hear me, ma?
Yes.
Sorry, what are the situations that we want to remove the outliers? I thought they are also important in the statistical analysis. Is there a situation where it may make one to remove the outliers?
It depends on the situation. When we first of all started, we from last lecture, we were told that the first thing that we're supposed to do is to familiarize ourselves with our data. So a way of familiarizing ourselves with our data is through the use of a box plot. When you get this graph, you see that outliers are there. The next step after detecting outliers is to check one by one those outliers. What might have happened? Maybe are they genuine observations? Are they there as a result of maybe recording error or some other types of error? So that we check them carefully. And if we now say that, okay, they are genuine observations, we retain them. We don't remove them. Do you understand? We don't remove them. But if they are not genuine and you are not comfortable with them, then you remove them.
Okay, it's understood now.
Okay.
I appreciate, ma.
Okay, thank you.
Hello, doctor.
Any other questions?
Yeah, I have a question.
Okay.
Is it possible to display this outlier in the box plot?
Please, can you repeat the question?
Is it possible to display these specific outliers in the values of these outliers in the box plot?
Yes,
like
of course.
We just have the dot and we don't know which outlier this one. Is it possible to display them?
Yes, if you look at the left-hand side, you see the mileage MPG. That one will allow you to know what those dots, what they stand for.
Okay, but okay.
Hello, ma.
Do you understand what I'm trying to do? Yes.
Okay, I want to ask that. Hello, ma. Can you hear me, ma?
Yes.
Okay, I want to ask that. I discovered that when you were teaching us histogram and also this graph box, you were talking about using by, using category. Please, what's the meaning of by in this context, ma?
You know, we are dealing with a univariate, as in just one variable. And the variable we are dealing with here is the MPG. We started with that. We specified that variable. We said MPG. And we plotted the box plot for MPG. If you check that, we got that box plot. This is the box plot for MPG. You can see the outlier here. From here, you can get the value, just as I said the other time, of this particular outlier. Okay, this is for MPG. But when we say by, we have a categorical variable somewhere, and that variable is the foreign. That's been categorized into domestic and foreign. So we want to look at MPG in the light of that foreign. That is why we are saying MPG now by foreign. So if you say by foreign, then we'll be able to have a better understanding of MPG. If we look at it from the angle of domestic, we'll get a better understanding of MPG if we look at it from the angle of foreign. So it gives us a better picture. So it's like you said.
Okay. If I get you, ma. So it's like the foreign and the domestic is part of the raw data that we are using for our analysis, right?
The foreign, yes, foreign is part of the variables under use. We started from there.
Okay, ma.
Okay, auto.
Okay, the by contrast, like we are trying to contrast the mileage in line of a foreign and domestic. How will it look in foreign? How will it look in domestic?
If you break foreign into domestic and foreign, how will mileage look?
Okay. Thank you, ma. I get it now.
Okay. So let's move on to bar charts. Bar charts. Let's clear. Again, we are using our use auto. Okay, we are not using use auto this time around. Sorry. Let's go to our example data set on file. Go to example data set. Example data set. example data set installed with STATA. Let's go to NLS W88. NLS W88.dta. NLS W88.dta. Are you there, please? Can I continue?
Yes.
Okay, so we are using that particular data set. So from the menu, let's close all these ones here. So from the menu here, we go to graphics. From graphics, we move to bar chart. So you can see another window coming up now. So here again, I noticed little changes. If you are using STATA 14, for instance, you will see that on that type of data, instead of having just two that I have here, graph by calculating summary statistics, graph actual data, you will see that you have about 4 bullet points there. You have graph of summary statistics, graph of frequencies within categories, graph of percent of frequencies within categories, then graph actual data. That's what you have there. So 2 are missing. 2, as in graph of frequencies within categories, graph of percent of frequencies within categories. Those ones are missing. But anyway, it doesn't affect, just as I said, it doesn't really affect what we want to do. So we can still go ahead with what we have here. And if you are using that setup, we just click the first box. It must have been clicked by default. That's graph or summary statistics. So I have a graph by calculating summary statistics. Just maintain that. Orientation, let's maintain vertical. You can choose horizontal, but let's maintain vertical. So under statistics to plot, let's maintain the first one, mean. Let's maintain that one. Then variables, we need to specify our variable. Here, the variable of interest is the wage. We need to specify that wage. Then submit.
Sorry, excuse me, ma. My own data set examples is not giving me any set of data.
As in use NLS W88.
I didn't see anything like that.
System use space NLS W88.
Okay, sir.
You have to call it out of STATA, system use.
Okay. Let me try again.
Okay.
Type system use, then space NLS W88.
Also, she needs to clear the old one. Clear the
I've cleared already.
Okay.
Yeah, so the best way is just type it out. I have the same challenge, so I typed it out and the data is loaded.
Okay, thank you. Okay.
System use NLS what, please?
NLS W88.
Okay, thank you, ma. Thank you, ma.
Okay. So now, after specifying wage as our variable, we click submit. If we submit, we will get this graph. You can see just one bar, big bar, for mean of wage. So this one is not informative enough. So we need to do some modifications to be able to get the right type of information that we need. So now let us go to categories. Let us go to categories now. So we check group 1. Under that now, let us select SMSA as our first grouping variable. Then the second grouping variable, let us select married. Then the third grouping variable, let us select college grad. Then we submit. You can see that we have the graph now, but we still need to do some modifications. Just like we said the other time, we can talk about the title, subtitle, notes, and some other stuff. So if we want to do that, we still go to our graph bar window, and then we go to titles. So under title now, we see title, subtitle, caption, note. So let's type something under title. We have average hourly wage. 1988. Women age 34 to 46. Then under subtitle, we have by college graduation, marital status, and SMSA residence. Then note, source, 1988 data from NLS, US Department of Labor, Bureau of Labor Statistics. So I think if you are using STATA 14 and above, if you don't put those quotation marks there, it will still allow you. So after that, you click submit. So you see that those information have been included now. You see that college grad, you know, we have married, college grad, then SMSA. Those that are SMSA and those that are non-SMSA. So the non-SMSA color blue, SMSA color this is wine. Then those that are married, they are subsumed inside the college grad or no college grad. So first grouping is whether it's college grad or no college grad. So then inside that now, you now have those that are single or married. As in those that are single or married that do not have college degree. Those that are single or married that have a college degree. And when you talk about those that are single or married,
information
yes, one is what I want to talk about.
You're looking at the salary of those who are not college.
Yes, that is the third one. That is what we are actually looking. The colors tell us that those that are non-SMSA, that are single or married, that have college degree, single or married, that do not have college degree. Do you understand? So those are the three categories. The first one, whether you are SMSA or not. Then further broken down into whether you are single or married. Then further broken down into whether you are you have college grad or you are not college grad. So, and we have the source of the data has been included. The title and the subtitle has also been included. So this is just an example. There are different types of bar graphs. There are different types of charts that you come across. So just as I said, you can check that STATA cheat sheet. You can check some other formats when you are just practicing on your own. You see all sorts, and then you save. Just as we've been saying, try to save all these commands. Send them to a do file. Save them so that if you have something that are similar to all these type of things that we are doing in future, you just copy them. You can see it very long. You just copy them and use them, and then you do the modifications as necessary. Please, do you have any question on bar charts? So that means I can continue.
Yes, madam.
Yes. Okay.
So I followed the same procedures as you did, but unfortunately, when I click execute, it keeps on telling me option marital not allowed.
Option married.
Marital not allowed.
That is because you did not put your information in inverted commas. That's right.
No, actually, I'm using STATA 16. It does not.
Why not try to in inverted commas and see?
I think.
Is it under categories?
If you put comma, it doesn't work. Put dot.
Is it under categories?
Put dot.
Yeah, try that.
Yes.
It was not working for me, and I put dot instead of comma, and it worked for STATA 17.
Okay.
Please look at it carefully.
Okay.
Please look at it carefully.
But throughout. Okay, I'm amending it right now and changing all the commands with dots.
Just before Marito status. Just before Marito.
Okay.
Just right.
Can I proceed?
Oh yes.
Okay.
Yes. The dots have accepted the command. Thank you. You can proceed, madam. Thank you.
Okay. So let's move to contour plots now. So we have cleared. So we want to use use auto. Use auto. So under these contours, when we say contours, is like when we are talking about percentage or fraction of points below a given value. For instance, if we say 20%, that means if we say 20% contour, that means we are saying that at that particular point, 20%, that 20% of what we have as our data set fall below that particular point, while the remaining 80% will be above. You can say 20%, can say 0.2. So at that point, 20% will fall below, the 20% of your data set will be below, while the remaining 80% will be above. And what do we use a contour plot for? If we have two data sets and we are thinking they should be from the same distribution, they should have a common distribution. Two data sets from populations that we think should have common distribution. So we can use contour plots, that's QQ plots. Is a little bit different from your Q norm. If it is Q norm, you compare with that of normal. But this one is two data sets that you think should come from the same distribution. So when you get your graph for the QQ plot, you will see that on the graph there will be another line, a 45-degree reference line that will also be plotted alongside the plots of your data sets, the two data sets. So if you want to interpret, you will now check whether the plots from your data set align with that 45-degree reference line. If there is alignment of something very close to that, then you say that they are from the same distribution. But if there is disparity, then that means that they come from different distribution. So to illustrate this now, we are under use auto. We generate two data sets, and then we'll try to see whether they have a common distribution. So what we do now is under our command, we generate weight E is equal to weight if not foreign. So if we check this now, you will see that weight D has been generated. You can see the variable now, weight D. That's for domestic. If you look at it, not foreign. If you say no, that exclamation mark means not. So not foreign means those that are not foreign. You know, the other time we said this foreign is categorical. Domestic, you can see domestic, then you can see foreign. So the command we use now says not foreign, if not foreign. So that means that you have values for domestic. So that is why we're having values for domestic here now. So if we return now, we generate the second data set. Weight F, weight if foreign, So if we look at that now, you see that if this one says if foreign, so all those that are domestic, they have empty values, they are missing, but those that are missing and those that are foreign, they have values. So those are the two data sets. Now we want to use our menu to do the QQ plot now. So now we go to statistics. From statistics, go to summaries, tables, and tests. So from there, navigate your way to distributional plots and tests. From distributional plots and tests, go to contour plot. So you can see the window now. From statistics, go to summaries, tables, and tests. From summary tables and tests, go to distributional plots and tests. From distributional plots and tests, go to contour plot. So this window will come, QQ plot. So you see under main, contour variable 1, contour variable 2. So under contour variable 1, we select weight D. Under contour variable 2, weight F. And then we submit. You can see the graph. This straight line here is the 45 degrees reference line that we talked about. And the dots that you see here, they are the plots from the two data sets. And just visually looking at what we have there, we can see that the graph is not in alignment with that straight line. So you can safely conclude that they do not have the same distribution. So you can also use your command. If you use command, it's already here anyway. QQ plot, weight D, then weight F. It will give you the same thing. So I think that's that about quick plot. So when we get to regression, so there are other types of this stuff that we talk about there, under our tests, whether our assumptions for using maybe your linear regression model, whether those assumptions, whether they are satisfied. So we still talk about all these Q norm and some other stuff. We still talk about them later. Can I proceed?
Yes.
Okay, thank you.
Yes, ma'am.
Okay, so let's move to scatter plots now. Scatter plots. So let's clear. Again, we are using 6use auto. We are using 6use auto. So from, when you say scatter plot, we want to get the relationship between two variables. We have left univariate now. Scatter plot is bivariate. So we want to test, we want to look at, examine the relationship between two variables. So from our menu now, let's go to graphics. Graphics. So the first one, the two-way graph, scatter line, etc. So we click that. So the next thing you see from that window, plot, if in, y-axis, x-axis, titles, legend, overall, by. So the first thing to do is to click create. Create. So you can see another window. You see plot 1. Choose a plot category and type. Then basic plot, select type. So that basic plot is already checked for us. So under that, under the basic plots now, we select scatter. We select scatter. Then under plot type, we have y variable. Y variable, we have MPG, let's select MPG. Then under the X variable, let's select weight. The Y variable is the dependent. The X variable is like explanatory variable, but we have two variables. I want to check the type of relationship that exists. So we have this now, then we click accept, then we click submit. So we can see the scatter now from left to right. So it's you can see that when we plot that is negative. The type of association that this one is bringing is negative because it moves from the left to the right. And you can see the command too, two-way scatter MPG weight. If you also try graph two-way scatter MPG weight, it will also work. It will also work. So I think that's that about how to plot a simple scatter. So if we want to, okay, just let's continue first. Let's move to fitting regression lines. We want to fit regression lines now to this scatter plot. To this scatter plot that we have. We want to fit the lines. We'll still talk about linear regression later, but now let's say we just want to add line to it, not just the scatter. I don't want to see the line. So we come back to our two-way graph. We click create. We change from basic plot to fit plot now, to fit plot. You see that under the fit plot, select type as come out. You see linear prediction, quadratic prediction, fractional polynomial, linear prediction with confidence interval, and so on and so forth. So again, we move to plot type. Our Y, MPG, our X is a weight. Again, we accept. Then we submit. You can see that the line has been added. So if we move the other way too, if we start from fit to instead of scatter, we can also get back to that particular place. Okay. So now that we have our graph, this one also applies to some of our those graphs that we have also treated. So we want to save. So if we want to save the graph, we just come here under this place here, we click save. You see that we have saved as type STATA graph.gph. So we save in our working folder, our working directory where we are working. It says save. So you say this one already exists. Let me add. Do you want to replace it? No. So let me add something else. Let's call it graph 1. Saved. So it's already saved now. I'll now go to where I've saved the graph. This is the graph 1 under STATA training. So I have it here now, it's open. Then I'll go to file. Then I'll click save as. I'll click save as. So now, whatever I want to do, I can now go to that format. Whether I want PDF format, I want a PNG format, I want TIFF format, and some other formats. So if we say PDF format, then we click save. So it has been saved in that particular format now. You can see it here, graph 1. So this is it. So by and large, we still have to do some other explorations to get some other details from all what we have been be talking about. You learn about the start graph editor. You put the title. You put the title. You put the subtitle. You want to change the color of this one now. You can change to a purple. If you click this, you can change to horizontal. And so many other things that you can also add using this start graph editor. So by the time you familiarize yourself with some of these things, there's still some other things that you will still discover on your own. And then you will get better with practice every day. So thank you very much for your rapt attention. Mr. Redele.
Hello, ma'am.
Hello.
I have a question.
Yes.
Okay, the question I have is that is it normal to first do this scatter and fit graph to know which type of regressions to run, whether linear or non-linear? I think the one we did by plotting the scatter diagram, then the linear graph shows that line passes through the middle of those scatter diagrams. So maybe linear can work for it. Things like that, just to be able to know, like a test before we select which type of regression to run, whether linear or multiple. Yeah.
Okay. Well, if we want to run our simple linear regression model, we have assumptions underlining the use of our simple linear regression. So we'll first of all check whether those assumptions, whether they are satisfied. So apart from that, when you do scatter plot, you try as much as possible to check whether relationship exists. You know, under regression, what you are trying to do is whether, for instance, now we have MPG and weight, whether weight is contributing something, has influence on that MPG, for instance. So in the preliminary stage, you can check, is there any relationship between this MPG and weight? So if you are able to examine whether there is relationship, whether something ties them together, you know, that because there are instances where some of the variables that are included as part of our explanatory variables, they have nothing to do with the dependent variable at all. They don't even have anything they don't even have any business being in that model. But because we have failed to carry out some of these small exploratory tests that we call small, because we have failed to check some of these things, we just include some of those variables that are redundant. We put them there. They have nothing to do with the dependent variable, and they are there, and they are contributing nothing at all. So if you remove them, they are not adding any value. So that's the essence of when you say you check scatter plot. Of course, you can use scatter plot for some other things that we'll still talk about, but basically to check whether relationship exists. Is it positive relationship or negative relationship or no relationship at all? So it's important that we do stuff like this to have a feel of what our data looks like before we even start the modeling. Have I been able to answer your question?
Yes, it's okay.
Good evening, Doctor. Thank you for the presentation around the scatter plots. I need some guidance on when I look at the scatter plots, like you said, it shows a relationship between two variables. So I'm looking at a scenario where we learned in class about the demand and supply. Is there a way we can plot such data on the same scatter plot where we can have the demand curve and maybe the supply curve running on the same scatter plot? Thank you.
You have your demand data, then you have your supply. So if you have that, you want to check whether there is relationship between demand and supply. Is that what you're trying to say? So you can.
Yes. How can I graph that data? I can. So kindly help me out on how we can do that. I'm assuming we have. Yes.
It's the same procedure. If you have two data sets, you have two variables, demand, then supply. Then you follow the process from graphics here to two-way. Then from your two-way, you select your variables. You go to scatter, basic plus scatter, then your Y variable, which one is it the demand that is affecting the supply? So you specify that under your Y, then you specify your X also, and then you accept and submit. Have I answered your question?
To some extent, yes, but now my scenario is I'm looking at demand, which has the particular prices for the commodities that are being demanded, and supply also having its respective prices. So I'm wondering on that scatter plot, can we have like the linear lines that you drew on the two scatter plots also crossing for the demand? We know those two curves, one which is negatively sloping and another one which is positively sloping on the same graph.
And the line, we can also include the line.
Hello?
We can also include the line. Hello? Can you hear me? We can also include the line. Just follow the procedure. The line will come out also. First of all, get the scatter, then put the line there. Just follow the procedure. Since you have your prices for the demand, then you have that of the supply. Just plot it and put the line to come out. And be able to say whether there's negative or positive.
I'll try it out, and maybe when I fail, I'll seek some guidance from you. Maybe after the classroom.
Okay.
Okay, thank you, madam.
You're welcome.